Welcome back. So in this video we are going to be working on registers, and a lot of this will be very similar to how Ben did it in his videos. However, similar to my previous videos, there will be a pretty significant difference, but we'll go over that when we get there. So this is my mess of wires. Again, I just want to prototype it on the breadboard first before I move over to Perfboard. So it's hard to see, but you got your 74 LS 173s right here and here behind this mess of wires, and one buffer 74 LS 245 chip, the octal buffer. So same thing that Ben did, and if I hook this up to power and clock, I can show you it working. So put power. And the clock line. So this is my enable pin right here, and it's pulled high right now, which means it will not be enabled, so I can turn this clock on and nothing should happen. I also have all the bits right now set to ones, so as soon as I enable this, it should flip all to ones. So enable it, and there you go. On the next clock pulse, it's all ones. So I can change any of these bit flags to low, and that should switch on the next clock pulse. Good. So as you can see, it's working. However, the video wouldn't be that interesting if that's all I'm going to be doing. So what I'll be doing here is going over my design for the perf board, and then going and building it. So let's get started with that. Okay, now let's do some planning. So I have my perf board here, and I have drawn out my 74 LS 173s and 74 LS 245s here. Just diagram it. So my goal is to try to minimize the number of wire crossings we're going to need, because we have to do jumps for all of those. So let's see if we can't plan something creative out here. So if you look at this diagram, I have labeled the important parts of the circuits. So on the 74 LS 173s, we have our ground power, we have our clock. This is enable, which we just tie to low, our load pin, our clear pin, and we also have 4 bits which go, basically input to output. So you may ask, why have I oriented my chips in a strange way? I have this one oriented right, this one oriented left, this one oriented right. You'll see that in just a second. So these two are exactly the same. The 245 is much simpler, also has 5 volts and ground, a direction, and when you pull it down, it's going to do this direction to this direction when I pull it to ground, and an enable pin, which we'll use to enable when it's outputting to the bus. And I have my bus drawn out. So what I want to show you is, by orienting the chips like this, what I hope to accomplish. So if I call this the first bit, or the most significant bit, I'm going to try to bring this one up, around, and into this position of the 74 LS 245. Same with the second most significant bit, and then the third, and then the fourth. So these are the top 4 bits of the 8-bit value we're going to store. Same on this side. So this will be the least significant bit, the second least, third, and fourth. So you can look at that as bit kind of 1 through 8. And you can see what I've done here is I actually haven't crossed any of the lines, so I should be able to do this without doing any jumps. In addition, if I use these as the inputs from the bus, I can do the same thing. So I can pull this to 1, this to 2, to 3, to 4, to 5, and 8. So you can see what I've done here is, again, I've also crossed no lines yet. And also for outputs, I can output to the bus in the same manner, as long as I stay consistent. I missed one. Well, I just shifted them all over, so you get it. like that. So then I'm going to have 8 bits of outputting to the bus and 8 bits inputting from the bus. So this is pretty good. I mean, I still have a few more signals to pull, so I'm also going to want to do a, let's call it a clock and a clear. And these will be header pins that I'll just insert into the perf board. And I'm going to want to do enable for the 173, enable for the 245. So those will also be header pins. So I'm going to have a couple of signals coming in. So the clocks I can tie together. Again, these will be jumpers, so I'm just going to draw these lines fairly rough so you get an idea. So clock and then to clock. The clears for the 173s. Again, these can be tied together. The load pins, I'm sorry, the clears go this way. I went the wrong way. So clears are there. This is the load pin and load pin. And then I have the enable for the 245 to this header pin. And that should do it. So, you know, only a couple of jumps and I have a pretty good situation here. Now this handles one of my registers, and that would easily fit onto this perf board with some LEDs up top. So I'll put the LEDs in line with all of these to indicate what the current value of the register is. So I'd have the LEDs along here. I'd have my 3 chips here, here, and here. And I can just connect to the bus. But the more I look at this, I realize I can probably fit more than just one register. So that's exactly what I'm going to do. So if you see here, I've drawn out the same chips, but I've inverted the way they're pointing. So this one's pointing left, right, left instead of right, left, right. And by simply taking this direction pin and pulling it to 5 volts instead of ground, now it's going this way. So that chip's taken care of. And these ones, I just need to flip everything over. So same thing, I can map bit 1 to 1, 2 to 2, 3 to 3, 4 to 4, 5 to 5, 6 to 6, 7 to 7, 8 to 8. And the same with the 245s. I can just carry these same bits across because I'm never going to be inputting and outputting the bus from the same chips. So I can call this register A and this register B only by switching this mapping from ground to 5 volts and flipping all the chips. I can also tie these clocks together with the same clock I already have, because I can put all clocks together, and the clear pin, which is this one, I can also tie together with the other clear pins, because when I'm clearing this computer, I'll be clearing all of the registers, so that's convenient. And I will have to do another enable pin, a 245 enable, and a 173 enable. And same thing, I will just put the load pins to the 173 enable and the enable to the 245 enable. So now essentially these 2 pins over here will control the B register, these 2 will control the A register, and they have a common clock and clear. And I don't have to cross any lines except for the 4 control lines, or sorry, 4 on the top and then 2 in the bottom, so 6 control lines. So that's the plan. I should be able to get 8 LEDs here, 8 LEDs here, my 3 chips across here, my 3 chips across here, a bus in the middle, and then my control lines on the side. So I'm pretty stoked about that. I think it's going to work pretty well. Last video was kind of a disaster. And oh man, did you see that? It's like my design just came out of the paper and into this perf board as I was talking. It's like somebody saw my last hour-long video of me struggling and said, I never want to see that again. Man, this is really exciting. So yeah, dramatics aside and bad acting aside, what I've done this time is I actually just went ahead and did the first part on my own. So I just did the A register up here, and I'm glad I did. I learned some things along the way, and what we'll do is I'll do the B register on camera, so you get to see that with hopefully a lot less stumbling like in my last video. So before we start, I'll give you a quick demo of how this works, and then we'll go on to the build. Okay, so this should look pretty familiar. It's my ghetto testing rig. So what I have my clear, my clock lines over here, along with power for the whole board. So these clear and clock will serve both registers A and B. I have also set up my A 245 clear enable and 173 enable. So this will enable the 173s or the 245. I haven't done another one yet. I also have this, which is going to go to the bus. So this will go in and out. I have my 8 LEDs, and I also have this set of header pins here, which is hard to see at the top, which will be going towards the ALU. So if I just hook all these up, so start with the clock, which goes here, and then I'll want to set up my clear line and set that high so I do not clear. No, sorry, set that low so I do not clear. So clear line low. And then I also want to set my 245 to high and my 173s to low, because these are load low. And the last thing I want to do is give it power, so let's put the power lines in. Actually, no, I also want to put a bit in, so since these chips float high, I'm going to put this in bit 7. And so we should see all the bits come in except for bit 7. So I put power onto this now. So if I pulse the clock, I should get everything but bit 7 come alive. I don't need to give the whole board power, that would help. Okay, let's see. Good. So you can see everything except for bit 7 is lit up. So good. So if I move this now, nothing should happen until I pulse the clock. So I'm going to move this over to bit 1 and pulse the clock. You can see bit 1 is now off. So good. That seems to work. Okay, so now that I have that working, what I want to do is do the bottom line. So I'm going to do 8 more LEDs here, along with the connections to the 173s, which is the same as these silver copper wires up here. So I'm going to put those on the bottom here. Do another set of 8 header pins, which will go towards the ALU for the B register. I also need to put another header pin into this side here, which will control the B register. So I'll have my A and B controls. I don't need another clock and clear, I can use these. I don't need another power, I can use these. I don't need another bus, I can use this. And I don't even need another connection from the 173s to the 245 because I can use this one, because I will never be using both registers to the bus at the same time. So these will be bus out, which will only be either A or B. For the ALU outs, I'm going to be using this one and this one, so those can be done independently for the adding. But for bus out, I could do A register out or B register out. I think Ben's design only had A out. I don't think B out was an option to the bus. This one will have the ability to do A out and B out. What I use that for, I have no idea. But so in the next couple minutes, I'll do another time lapse of me soldering in the silver copper lines here, the LEDs, and making all the connections to the signal lines on the bottom. So stick with me, let's do it. Okay, so all I've really done so far is just connect the common pins. So the 4 bits to the 173s and the 8 pins to the 245. So they're crossed across the two registers A and B. I also connected up the header pin, the 8 header pins for the ALU. So next I'll be working on is putting in the 8 LEDs and connecting the lines. So similar to how I did it here, where I jumped all of them over, I'm gonna do it here. So I'm gonna jump it, a 1 to here, 2 to here, so all 4. So I'm just gonna connect all of them across with silver copper wire on the top side, like I did with this top side here. So you didn't see it, but I connected all 8 bits on the top here. So I'll be doing the same thing with the LEDs in the next step. Get to it. Okay, so what I'm going to do is hook this ground lead up to what should be a common ground and take this little resistor and touch each positive to see if it turns on. So let's flip it up so we can see it. So 1, That was good. 2, 3, 4, 5. Nothing on 6, 7. All right, 6 and 7 didn't glow. Let's see if I missed the ground. So we put the ground on 6. I missed the ground, that's all. And 7. Also missed the ground. Okay, let's fix those grounds. Okay, 6. Oops. 6 is fixed, and 7. All right, so 1, 2, 3, 4, 5, 6, 7, 8. All right, cool. They're all connected. Okay, so what I've done is now the LEDs are secure, I've actually just bent all the leads over to their appropriate places. So 1, 2, so this one, 1, 2, 3, 4, 5, 7, 8. So we're all bent over, so I'll solder all of these ones over into their appropriate places. Let's do it. Okay, now I got all the LEDs soldered in. Let's connect my ground wire again here. And then let's see if all of the LEDs work. So I should be able to touch each of these and turn it on. So 1, 2, 3, 4, 5, 6, 7, 8. Cool. So those all seem to be working. So now the next thing I need to do is solder in my 2-pin header here for the enable lines for both the 173s and the 245s, and then connect up my ground, VCC, and then all the various clear and enable lines. So let's do that right now. Okay, now that should do it. I have all my lines hooked up reasonably well, so let's do some continuity testing and see how we did. So first things first, let's test our grounds. So ground should be here and here. Yep. And there should be a ground here. Yep. And should be a ground here and here. And here. Alright, those are all the grounds. Try the 5 volt. Should be, and I should test the ground to the other ground, which should be this pin. Yep. And these two. Alright, ground plane is working. 5 volts. Here, here, which is the direction. 5 volts. And then 5 volts here. Good. We test one of the other planes like this one. Okay, 5 volts working. The load pin should be these two, so they're connected, and should connect to these two. Yep. And then I should have, that's it, I think. Yeah, that's all my pins. There should be no other ones mixed. Okay, let's test it out. Okay, let's get her hooked up. Okay, to start, let's just test the new bottom row we created. So let's add our clock and take our clear high, no, sorry, glow, because we don't want to clear it. I also want to take my enable 173 pin low and enable 245 high, so that only the 173 is enabled. And then I also want to add my power, which is here, and my ground, which is here. Alright, so when I power this up, it should read all ones. So let's do that. Make sure there's no stray lines that will short me out. So I pulse the clock, it should read all ones. Cross your fingers. Yes! Okay. Let's take each one of them low. First, nice. 2, 3, 4, 5, 6. Oh man, I'm getting nervous. 7, 8. All right, good. Well, that's pretty good so far. Let's try the next thing. Let's see if we can plug in our top line. So what I want to do is, I don't think I need whatever this wire is for. Pull this one out. So I will take my top line and make same. Actually, first thing I'll do is take these both high, so that these are disabled. So now both of these are high. So if I were to put another one of these low, it shouldn't make a difference. So if I put that in there and press pulse, yeah, nothing. Okay, so the bottom line is disabled. Take the top line and make the same thing. The 173 is low and the 245 is high. Now I pulse the clock again. They should be all ones. Good. I should be able to affect just the top line. So this is something in the bus right here. So I should be able to put just something into the A register. Perfect. That is much better than I expected. So I haven't broken anything. And actually I can get even more creative. So let's try something more advanced. So I'm going to put a pattern. Let's just put a pattern like this into the A register. Okay. And then I will take the A register both high so that it locks it in. So now if I move this, to pull one of them out, you can see nothing changes. Perfect. So pull both of these out. So now I have nothing plugged into the middle for testing. However, I should be able to move this pattern 10110111 to the B register by simply enabling the bus and then enabling the input on register B. So if I take this first register and just make the bus, which is the white wire, low, and on the second set of wires I will take the blue wire low. So this should enable the B register and enable the A register out. So I should see these two move down. Oh my gosh. All right. I think we have a functional register. So I can also try. So if I'll push something from B to A too. So let me take the B register. Sorry, the A register first and disable both. I don't want anything outputting at all. So I'm taking the A register. I should make this more organized, but I'm not. Okay. Take both of the A registers high, which will essentially disable them. Okay, A register is high. So you can see obviously it's in the bus, so something came through. So if I put a pattern into the B register with my wires here, so I'll pull these first two low. Now on the B register, I want to take them both high. And now I can pull these out, and again, nothing should happen, which it doesn't. Fantastic. Last step, I should take my B register and take the 245 low, which is this green wire. So this 245 goes low. And then the A register, I want the 173s low, which is this teal. So to the teal one low, and that one high. So now when I pulse, it should move this pattern to here. It did not. What did I do wrong? Do I have the bus output enabled? So do I have the teal one low? I do. And I have this. That teal low, that's both teals low. All right, time to troubleshoot. Okay, so I think I actually know what it is before I even start. If you look at my really rough design document here, the important thing you're going to see is, remember I told you how if I flip this direction, it would go up, which is true. However, I also rotated it. So you can see this goes from dot down. This also should go from dot down. This should be ground. So what's happening is, the reason that this is not going from B to A is because I have the direction backwards. This direction should also be grounded just like this direction, because when I flipped it, it took care of the moving from down to up essentially. So if I ground this pin instead of putting it to 5 volts, that should fix it. So let's do that really quick. Also, quick note while I was taking this apart, the pin I have backwards is extremely hot to the touch. So clearly, because I was running it almost in a circle, right? So it was taking the input and trying to push it in the same direction as the LEDs. Yeah, that made it extremely hot. So if you can do this yourself, be careful about your directions, because chances are I could have burnt. I may have burnt this chip out, but hopefully not when I flip the direction. Let's see. But it is, yeah, very, very hot to the touch. So, word of warning. Okay, I have got it all hooked up again. Right now, they're both in disabled mode. So both the 245s and 173s on both registers are disabled, so I can pulse the clock all I want and nothing is going to happen. Now let's take my B register and take this teal line low, which should pull all 8 bits high. Does, perfect. Now if I take any 2 bits, let's just do the first and last for instance. I'll take those low and pulse again. Those are good. I can pull these out now. And then take teal low high again, which should do nothing. Oh, no, it did something. What did I just do? Did I pull the power up? I pulled the power out. Sorry about that. Let's try that again. I flicked the power cable by accident. Enable the teal line low. Okay, perfect. Teal high again. Pull these out. So now I have that on. I want the blue to go low, which will enable the B register to output to the bus, so it's B out. And then I want to take the teal on this one, take it low, which will mean A in, so it should take this pattern in the B register and move it to the A register. So, perfect. Okay, I'm reasonably happy calling that good. Yeah, I think if I pull these both high again now, that should just do nothing. Yeah, so that's it. I have both A and B registers working. They can both output to the bus. I haven't tested these 2 yet, but that will be for the next video, because in the next video I'll be building a bus so I can test these outputs more easily. The next one should be very short, and then I'll be working on the ALU, which I think will be a fairly long video again. So thanks for joining me today, and I will see you next time. Bye-bye.